About the lens, but before to discuss about the lenses, I need to review a bit refractive index. It's very basic level. So refractive index, sorry. This is the basic equation of refractive index. So N is equal to sine I over sine R. So I for the incident and R for the refraction. So what do you see in this diagram? That light is coming from one medium and entering to another medium. Okay. We assume that the first medium is air and refractive index is N2, and the second medium is a glass or water with refractive index N1. Here we are considering glass, so that is why I wrote 1.5 here. So if we draw the normal here, you can see that the I with the incident ray and R with the refracted ray. What is happening here when the light is coming from air and entering to the glass? So it's bending towards the normal, bending towards the normal here. The case will be opposite if the light is coming from glass, okay, like this, from the glass here and entering to the air. So in this case, if we draw the normal here like this, so this is I and this is R. So what is happening? The light, the refracted ray is going away from the normal. Okay, so this is the case here. It's because of this, that refractive index of air, so refractive index of the glass is more than refractive index of the air. So that is why light is bending towards the normal. And here, what is happening? That its light is coming from a glass and moving towards the air. Okay. So in this case, the light ray, the refracted ray, is going away. Okay. Here, the N1 is greater than N2, and let's suppose this one we can call it N3. Okay, so this is air. So, and here, what is happening that N3 is less than N1. So, when the light from air to glass, the refractive index of the air is less than the refractive index of the glass, the refracted ray, it bends or moves towards the normal. Okay, and the opposite, like when glass to air, then the ray will be moving away from the normal. Now if we move to the lens, first thing we need to know that there are two kinds of lenses. Lens is, I mean, simply you can say it's a piece of a glass or any transparent material. Okay, there are three kinds of converging lenses or convex lenses: biconvex lens, plano-convex lens, concavo-convex lens. So both sides convex, one side plane, one side convex. So one side is concave, okay, and one side is convex. So that is why it's called concavo-convex. These different types of converging lenses or convex lenses, they have applications, but here we are not discussing. Now, if we move to the other diverging lenses, diverging lenses or concave lens. So three types here you can see, that biconvex, biconcave, plano-concave, and convexo-concave. What is happening here? Both the sides are concave type. One is plane, one is concave here. Okay. And one is convex and one is concave. That is why it's called convexo-concave. So these are converging lenses. Okay. Light is converged when passed through to a one point. And these are diverging lenses. And light diverges. Light diverges in this case. Now there are some more basic things. It may help you to understand more. Lens and the refractive index. Okay, first we are considering the diverging one, converging one, which is a convex lens. So what do you see in this first diagram? And what do you see in the second diagram? In second diagram, this is the normal case, what we observe. Okay, because light always from the air to glass. Okay, lighter medium, denser medium. This is the case when light from denser medium to enter into the lighter medium. Okay, so if N2 is greater than N1, what is happening? This is the principal axis. Okay, so light is going away from the principal axis. If N1 is greater than N2, okay, then the light is converging. It's moving towards the principal axis. Okay. So let's suppose if this one, the N2 is greater than N1, and this is air. This can be any transparent material, can be glass, can be water. So in this case, this kind of shape, so what is behaving as a diverging lens. So all it depends on the refractive index. And here, which is a normal case, the light is converging because N1 is greater than N2. So N1 can be glass or water, or N2 is air. Okay. So things are depending on the refractive index, not on the shape actually. Okay. So now if we move to the next slide, the concave lenses. Here, this is the normal. This is not the normal case. This is the normal case. Figure 1, figure 2. Whenever we have any concave lens, the light is always diverged, like this one. It moves away from the principal axis. On the other hand, if N2 is greater than N1, N2 denser medium, N1 a lighter medium. Okay, so in this case, this kind of shape behaves as a converging lens. So the light is focused at certain point on the principal axis. So light is coming and it's converging. So let's suppose if this one is any dense material like oil, water, and this is a piece of any kind of space, empty space, or contains air or whatever. In this case, this concave lens behave as a converging lens. Okay, so the things are depending on the refractive index. And here this is a normal, what we observe in a daily life, that N2 is definitely like air, and this one is any dense material. So light is diverging. Light is diverging. So things are depending on refractive index. One of the examples you will see on the next slide here. This is any air bubble. Okay. Sorry. This is any air bubble. And around this air bubble, there is a water. So this is water. N2. And the air, the refractive index of the air is N1. So what do you see here? The light passing through from water to the air bubble, and it's diverging. Okay, because cases like refractive index of the water is greater than air. Okay, so this is how you can understand the properties, you can understand the lens, but all these things are depends upon the refractive index. So any bubble in a water, the shape is like a convex, okay, convex lens, but when the light pass through from water, coming from the water and pass through this air bubble, the light is diverging, going away from the principal axis. These are few things I feel that, I mean, it is good for the people who are interested in optics to know. And I hope it will help to understand more about the lenses and these kind of things. In my next video, I will explain about the lens more, like the ray diagram and image formation. So until then, goodbye. I hope you will like these videos which I am uploading in these days. It's more like giving you basic concepts about the optics. Okay, then see you in the next video.